This video is a guide to calculating electrical power. So let's start by looking at the equation. Power is equal to the current through an electrical device multiplied by the potential difference across that device. Remembering that power is measured in watts, current is measured in amperes or amps, and potential difference is measured in volts. So you may have heard of potential difference referred to as voltage in the past, and you may know that the power supply from the mains electricity in the United Kingdom is 230 volts and 13 amps. Now, this power equation is different from the previous power equation we've looked at. However, it is the same power. So, if I had the energy and the time taken for that energy to be transferred on a particular device, that would be equal to the current multiplied by the potential difference. So the equations can actually be linked together, and we will look at that in a future video. So let's start by looking at a simple question. An electric fan is plugged into a socket supplying 230 volts. An ammeter reading shows that the current going into the fan is 0.2 amps. Calculate the power of the fan. So we write down our equation. We substitute in the numbers, so we replace I with 0.2 and we replace V with 230. That gives us an answer of 46 watts. So if we were to look at power equals energy over time, we would have that there are 46 joules of energy being transferred every second. A light bulb is supplied a current of 0.6 amps. The potential difference across the terminals of that bulb is 100 volts. Calculate the power of the bulb. In this case, again, we simply write P equals I times V. We replace the I with 0.6, the V with 100, and that gives us an answer of, no surprise there, 60 watts, the most common light bulb used in Britain. Finally, we have a kettle plugged into the main supply which operates at 230 volts. It receives a current of 9.0 amps. Calculate the power of the kettle. So again, we write down our equation, we substitute in the correct numbers, and that gives us an answer of 2070 watts. Now in this case, in our question, we have a maximum of 2 significant figures in one of them. So what we then do is we simply round to 2 significant figures, giving us that the power is approximately equal to 2.1 kilowatts.